your
Recording
graph is
in
like
progress.
approaching these lines, right?
Mhm.
But there's our graph. So not too bad. And I think what the book also points out is like that this distance is 4. And this distance is 2√5, right? But I mean, based on everything you've had, it shouldn't be a problem. And that my graph is like not perfect by any means. So we will not have you graph this on the test, by the way, but your homework will probably ask you to do so. So just make sure you, as soon as you get these, like the vertices, the asymptotes, the foci, and your B value, right? As soon as you get those, you can do the square or plot those points exactly. And then from there, you can just sketch the rest, right? Or the curve. I think there's a way you can click on like a curve and connect points. And you should be able to do that without too much problem.
For the asymptotes you got on the graph, I don't get how you got like it looks like 3, like -3 over and then up a couple. Like, how did you get those 2 points?
Oh, so this is not right. Like, okay. So what I did was I said, if I plugged in, so if into like, just think of into this equation, if I did x equals square root of 5, which the square root of 5 is like 2.1 or 2.2, something like that, right? So if I plugged that in, I would get 2√5 over 5 times √5. And I was doing that to get rid of the √5. And in my head, and I was doing this in my head, so maybe I did this wrong. So √5 and √5. So this would be like 2 times 5 over 5, which is just 2, right? Mm-hmm. So I was saying, oh, and I totally counted wrong, or did I? So I was saying it should have been like 2 point, like this is maybe square root of 5, like 2 point something. And then I was going up 2. So I was just starting so the rest of it is just inaccurate. I was just making a dotted line, right? Okay. That's how I got those points. And same thing over here. I was saying, oh, if it's negative square root 5 and then up 2, like there's my next point. And then I was just like sketching. So whatever I sketched on the dotted lines, they are not accurate. Okay. I did not take enough time for that. Yeah. Okay, so hopefully that makes sense. I would say as long as your vertices and I didn't even graph the foci, but as long as your vertices are right and your box, like, and you're in the right direction, right? Because if your vertices are right, you're going to have a graph in the right area. Like if your graph ended up being a point here and like this, that's totally not right, because that's assuming the wrong transverse axis, right? So I think once you get kind of those main points, it should be fine. And we didn't graph the foci, but we could, right? So it was 0, 6, and 0, -6. So 1, 2, 3, 4, 5, 6. So you could have graphed those. I don't know that it needed you to, but there we go. So now this was centered at 0, 0. So now we want to look at what does it look like centered at HK? Well, it's exactly the same thing. And okay, in this case, it does say although A and B could be anything, they could be big, small, whatever, but they are assuming here that it's positive, probably just because it can get a little crazy, or because they put plus and minus, and if it was negative, it would be minus plus, like they would just flip flop. But anyway, so now if we're centered at HK, we no longer have the X and Y axis as our reference because we're not centered at the origin, right? So we either have a transverse that is horizontal, which is similar to the X axis, but not the same, or we have a transverse that is vertical, similar to the Y axis, but just shifted either left or right, right? And so these equations, these equations like look almost identical, but we shifted it with this H and K, right? And just notice like the order that things are going in, like X minus H. Okay, my pen is being super weird. I hope it's not dying. So X minus H, like the H still always goes with the X, even if the vertical is our transverse, right? Okay, sorry. I got really worried that my dog was chewing something he shouldn't have been, but he has a bone, so he's good. Okay. So just notice X and H always go together, Y and K always go together. And then for our asymptotes, they're shifted. So it's always Y minus K equals, and then it's based on your if the transverse is horizontal, it's B over A. If it's vertical, it's A over B, right? And that's your slope. And then the X minus H and the K, like that, the H and K are built in here. Okay. You could also think of it if you wanted as like plus K on this side and get rid of it over here, but it's up to you. I think they like to keep the Y and the K together because it's a little bit easier to remember, I think. And this, keep in mind that these equations that are given to you here, so this equation and this equation, these are in point slope form, not like what mx plus b, what is it, slope intercept form like before. So they're point slope form, and they pass through the point HK. That's like their X1 and Y1, if you want to think of it this way. Now let's just label real quick what's going on here. So the blue dots are still the vertices. So blue are still the vertices. And then the red dots, well, okay, that's the center of the box, so kind of ignore that. But these red points are the focus points or foci, right? And then HK. Oh, okay. So let's do this. So this point in the middle, this is your HK. So instead of being centered at 0, 0 in that, like the box, like that's the origin, it's now centered at HK. What was the point slope form? Point slope form, okay, so if you don't remember, point slope form is Y minus Y1 equals M times X minus X1, where M is the slope and X1, Y1 is a point on that line. So notice how our new origin is HK, and so the asymptotes, they both are going to pass through HK, right? Both of these. And so that's why the equation involves H and K. Oh, and I didn't prepare, I'm going to skip this Desmos construction, even though it's probably really cool. So I highly recommend you check it out. But I just want to try to get through as much as possible tonight. So yeah. Oh, and sorry, that was fast. Okay. So number 3, so we have, I think, 2 or 3 more examples before, oh man, maybe we have like 4 examples before we move on. Okay. So number 3 says graph the hyperbola, identify the center, vertices, foci, and equations of the asymptotes. Okay, so we've got a lot to do, but it gives us, this formula gives us almost everything we need, right? So first, I see that X is first, so I know X is the transverse, or well, okay, not the x-axis. I know it's horizontal, right? So I know that this is like X minus H, this is Y minus K, and we can figure out what everything is, right? And this is my A, or A squared, so A is 3, B is square root of 7, right? Which is like 2 point something, right? It's good to know just what it's between. So it's between 2 and 3. You don't need the actual decimal for now. But then we can also see, so we know because of this, what I highlighted, the transverse is horizontal, right? And then A is 3, B is this, and then the center, which is HK, this is, what is H is 4, and K is -3, because it's Y plus K, right? Okay, so this is good. And now we can find the vertices, and we can find the asymptotes, and then solve to find the foci, right? So first I'll start with the vertices. So the vertices are going to be from, if I graph this new center, so 4, 1, 2, 3, 4, -3, 1, 2, 3. Okay, so here's my new center. And I know the horizontal is my transverse. And I know A is 3. So usually we would go from 0 and we go 3 to the right, 3 to the left, right? This time we go from 4, -3, and I go 3 to the right, 3, and 3 to the left, 3. And these are my vertices. Okay, so those points are, what is that? 1, -3, and 7, -3. You could also just add, okay, I'm graphing it and showing you visually. You can just add the A value to the component that is your transverse. So where the horizontal is the X, right? Where basically our transverse is horizontal, like the X axis. So we could just take 3 and add it to 4 and then subtract it from 4. And that's how I got 1 and 7 for these vertices, right? So I've got my center, I've got my vertices. Now I can actually take B, which B is square root of 7. So I'm going to say between 2 and 3, right? So I can estimate like, okay, from the center, B is approximately 2 point something, right? So 2 and a little bit up, and and 1, 2 and a little bit down. And my box, if I wanted to kind of sketch that box, it looks like this. Oops, well, okay, it's not perfect, but you know, I had a little dip over here for some reason. So my box looks like this, right? And so I know that my asymptotes, I mean, we'll have to figure out what those equations are, but they're going to be something, they're going to look something like this, right? Because they go right diagonal through the box, okay? And so let's get those. So my asymptotes, so these are going to be, remember, look at that equation up here. So that's, if you're wondering, like, how am I remembering this? I'm just referencing the equations above. So y minus k. So one of them is y minus -3. So y plus 3 equals, and then I have a over b, or, oh, sorry, I have b over a. So square root of 7 over 3, and then times x minus h, and h was 4, right? And then the other one is the exact same equation, but negative square root of 7 over 3, and then x minus 4. Right? And so last but not least is to find the foci. And this is still c squared is a squared plus b squared. So 9 plus 7, which is 16. And so c is 4. So that's nice, right? So to get c, or to get the foci, you're just moving 4 away from the center, right? So again, you could just take the center, 4, -3, and subtract 4 from the x value, and then add 4 to the x value. So my foci points are 0, -3, and 8, -3. And they would go here and here. And then if I wanted to connect this graph, it would look something like this. Oh, geez. Okay. Okay, ignore my like really poorly drawn curves, but something like that, right? Okay, and now the next question. So that was kind of doing everything, like getting all the foci, the asymptotes, the vertices, getting all that information, and then graphing it. Now this next part gives it to us. So the equation that we were given up here, this lovely equation and all the equations above, this is what we call standard form. I don't remember if we talked about this last time, but maybe we did last week. So this would be standard form of a hyperbola. Now, this is also a hyperbola, this equation that they gave us, but it is not in standard form. So the directions here are write the equation in standard form. So we have to do a little trickery again, just kind of similar to last time, I think, with ellipses. And we're going to start. So we look at what we have here, and remember we couple the X together and we group the Y's together, right? And then we move this number over here, right? But instead of just doing X's, Y's, and moving on, we start with the positive variable. So I'm going to say start with the positive term. Like one of them is going to be negative, the X or the Y squared, the X squared or the Y squared, because this is okay. If one of them is not negative, it's not a hyperbola, right? So one of them has to be negative. And I'm talking about the squared terms. One of them will be negative. And so we start with the positive one. So I'm going to say 5y squared minus 80y. And then say minus 4x squared minus 40x equals negative 200. Okay, that's how I'm going to rewrite it first. Then I'm going to say, okay, let's take out a common factor. Like we can take a 5 out of these. We can take a 4 out of these guys and rewrite. So let's do that. So now I'm going to say 5 times y squared minus, what is that? 16y? Oops. And then plus I'm completing the square again. So plus blank. And now I'm going to take out a negative 4 so that I'm left with x squared plus 10x plus blank. Okay, because when we complete the square, it has to be positive x squared or y squared, but we can just move that negative outside and it's still there, right? It's just you have to be more careful, I think, when rewriting like this. And then we still have equals negative 200, okay? So now I'm going to complete the square with my y values. Remember, I take this, I divide by 2, then square it. So 16 divided by 2 is 4, squared, oh my God, divided by 2 is 8, wow. Squared is 64, so I'm adding 64 here. Now keep in mind on the other side, so normally I would say plus 64 minus 64 all inside the parentheses, but I'm also multiplying it by 5. So I'm technically adding 5 times 64 to the left-hand side. And then on the right-hand side, I also want to add that, and it's 320. So if it helps you, this is 64 times 5, right? If it helps you to write that. And then for the x, I'm taking this again, I'm dividing by 2, then I'm squaring it. So I get 5, and then 5 squared is 25. And I'm also multiplying this by negative 4, right? Because technically, I'm not just adding 25, I'm actually adding 25 times negative.
Your screen is freezed. No voice.
Yep, finally gave up. Good man.
All right, we're back to losing me, right? This is great. Wow, I don't know what's going on, but let's try to keep going and I'll just deal with my computer in a bit. This means I won't see the chat, so people unmute yourself and you won't see me for a bit, but maybe when we switch to 11.3 notes, I'll try to log back into my computer. I don't know what is happening. Oh, my computer might be dying. Okay, this could be user error. But it still shouldn't have logged me out. So I'm just gonna plug that in. Okay. So hopefully you can hear me and you're still with me. But I'm gonna write y minus 8 squared and then minus 4 times x plus 5 squared, right? And when I do this, on the other side, I get negative 200 plus 320 minus 100. Okay, so this is actually just 20. Now remember, I need 1 here to be in standard form. I need 1. So I have to divide everything by 20. Okay. And so when I do that, I can cancel this to be 1 and this to be 4, cancel this to be 1 and this to be 5. So I end up getting y minus 8 squared over 4 minus x plus 5 squared over 5 equals 1. And here's my equation, right? And it doesn't ask, but the center of this equation is negative 5, 8, right, is HK. And remember, H is here, K is here, because H goes with X and K goes with Y. And this has, because Y is first, this has a vertical oh my gosh, I can't spell. Transverse axis is vertical. Right? And we know that because the Y is first. Okay. All right, so number 5, we'll keep going. Please say something if this isn't working out or if you can't see or something happens, because I can't see you guys. So number 5 says determine the standard form. Again, we want standard form of the equation of a parabola. This time, instead of giving us this non-standard form, whatever, I don't remember what that is called. Now they're giving us the actual points and asymptotes, right? So we have to kind of work backwards. So we have the vertices. So we know that from these vertices, and let me see, I think this is centered at 0, 0 because look at this equation. So center is the origin, which is nice, right? And we know that we have I thought A would be 3. Oh yeah, A is 3. Okay, so we also know just from this that because y equals because sorry, I'm losing my mind. Because the 3 and negative 3, the center is 0, 0, and because these numbers are in the x coordinate, we know that the x-axis is the transverse. Okay. And because from the center, this one doesn't change. And so x-axis is our transverse. So if we were kind of graphing that, right, it would be like here and here. And so we know the graph is going to be, okay, this way with, some sorts of things going on. Okay, something like that. We don't have to graph it. We just need to find standard form. But then we also know because x is the transverse, we know y equals b over a times x, and plus or minus, right? So they have the plus or minus here. And so what that means is, and we know that a, we also know this number is a. So a equals 3. So these are all the things we know. We know just based on what we're given. Now I'll start writing maybe in green the things that we can find based on this. So we know that y equals b over, maybe this color isn't so good. Let me, let's pick something else. Okay. So y equals b over 3 times x, and it also equals I'm just picking the positive one, but it equals square root of 3x. So this tells me that b over 3 equals square root of 3. And this means that, maybe I shouldn't do equals. This means that b is square root 3 or 3 root 3, right? Or it's the square root of 27 or something. And so if we did, in order to write this equation, we're going to need b squared. So 3 root 3 squared is 9 times 3, so it's 27, right? Because this is 3 squared times 3. And so we're getting really close because actually, or maybe we're there, because we have b squared. Like, what do we need? So standard form with centered at 0, 0 is x squared over a squared minus y squared over b squared equals 1. And we had a from the beginning. It was 3. And we just needed to get b, or b squared, really. And so now, actually, we can just write this equation, x squared over 3 squared, so 9, minus y squared over 27 equals 1. And this is our standard form of the equation.
Cool.
Yeah, I mean, that works, right? It's working out okay. All right. So now we talked about this last time, the eccentricity of an ellipse. So now we're going to talk about this in regards to a hyperbola. And then I think I'm probably going to only do one. Maybe I'll pick 2 of these examples, but I think I'm only going to, 1 or 2 of these 4 examples, because we have, number 6 has these, and then we have 7 and 8. And oh my God, 7, 8, and 9. And then this is a review. So I might skip this extra practice and like one of these others, but we'll see. I just want to try to have time for everything. So, or maybe I need to move faster. So again, the eccentricity is C over A, very similar to the previous, right? And you know that C squared comes from your foci. It's A squared plus B squared. And in this case, our eccentricity is going to be greater than 1 always, is what we have here. So if we want to find this, right, first we're going to look at A and B, right? Or this is A squared and B squared. So, and what we do with that is we look at these vertex points in relation to what this is looking at is the vertex points in relation to where the foci are. So in this case, the foci would probably be really close. I mean, actually, do we actually calculate this? Yeah, maybe we should just calculate it. Okay, so if we're going to calculate this, we would get A is square root of 15, B is square root of 2, right? And so C squared is 15 plus 2, which is 17. So C is square root of 17. E is C over A. So it's square root of 17 over square root of 15. Yikes, right? So we would rationalize this. And this is going to end up being the square root of 17 times 15, which is 255, divided by 15. And this we're going to want a decimal for because that's just not helping me. So I did get that. It was like 1.07 or 0.65 something. So this is close. Notice how this is close to 1. And we consider this to be low eccentricity. And you can think of it because that it's low, because if we're looking back at the graph, these, the distance here is a little bit smaller. Now you can imagine that in this next example, the distance here is a lot bigger. And so maybe we'll get a bigger eccentricity here. Okay. And so let's take a look. So we would get A. So again, it's still A squared and B squared, right? Doesn't matter which is which. That's the order. So A is 5, B is square root of 24. And notice how in this case, A and B are actually really close, whereas in the other case, A and B were not close in number, or A squared and B squared were not close. Okay, so C squared is going to be 25 plus 24, which is 49. Okay, so that's nice. So C is 7. And then our E is C over A, so 7 over 5, which is exactly 1.4, right? And this is a higher, I mean, it's not crazy. Like in the scheme of things, they both still look like 1, but 1.07 is very close to 1 compared to 1.4. Like if you're looking at a scale between, 1 and 2 or something like that, or you could multiply these things by 10 and see, if you're looking between 0 and 10 or 10 and 20 or something like that. Okay. So this we consider a higher eccentricity. Okay. And if you graphed the foci here, they would be a little bit further away from, like, if we were to actually graph this, they would be further away from the vertices. Yeah. And you could think of it like a Pac-Man as well. Like if you like had, okay, this is like Mr. Pac-Man and this is like Miss Pac-Man over here or something. Oh, that's not right. Going this way, right? So you could think of it like Pac-Man, where the bigger the mouth, like he can eat way more for Thanksgiving, right? And we're all jealous or something. But the smaller, so in this case, well, it still looks really big, but like this less food maybe could fit in there or something like that. That's lower eccentricity, whereas more food can fit in the other one. That's one way to think about it. I think that was a silly way that like another professor had told us to think of it. Okay, so number 7 says to give the equation of the hyperbola in standard form whose vertices are these and eccentricity. So now we're not given, like in this previous one, right? We were given the vertices and the asymptotes. Now we're given the vertices and the eccentricity. So remember, this is C over A, okay? And this, the vertices, it looks like this is not going to be centered at 0, 0 because there's no zeros in the vertices, right? And notice how these numbers are the same. So that tells me that this is going to have a vertical transverse axis, right? Because the x values are the same and the y values are different, right? So because it's vertical, we know the standard form is going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. This is the standard form, okay? And if we look, like if we think about a graph real quick here, and we think about -4 and then, okay, 13. Okay, maybe I should have gone by 2s. 2, 4, 6, 8, 10, 12, 14. Okay, so something like this, right? And then -1, -2. So -4, 13 would be like here, and -4, 1 would be here. If you wanted to find what's exactly in the middle, so in this case, it's nice because it is even. We can like go one at a time. You could say, okay, go up 1 and then go down 1 and then go up 1 and down 1. And you're going to find that if you do that, in the exact middle is the number over here, 7. Okay. And you can do this because 13 minus 1 is 12. So there should be like 6 units above and 6 units below. Right. And that's how we get to 7. Okay. And so from there, we can say that HK is -4, 7, because like this is clearly the part of the vertex, since it's the same on the axes. So we know like these would be our vertices, and this axis is going to be our transverse axis, right? So -4, 7 is going to be our center, which is what we found there, right? And so that's going to help us. So far, if we look at this equation, we found H and K right off the bat, which is really nice. We can also find A really quickly because C over A, right? So A is 3, right? Not necessarily, right? Because, okay, I'm sorry. This is true, but it could be reduced. So this is my bad. I mean, I wonder if it would still work out. But in this case, you also have to consider the distance. A is actually 6 in this case because A is technically the distance from the center to the other points. And so this fraction is probably just reduced. So A is actually 6 and it would come from here. There are other ways to find it, but that's where that would come from. But then what we know based on this is that 5/3 has to equal C over 6. And this is how we can get B, because we can get our C value first and then use the fact that C equals C squared is A squared plus B squared. So we know that E is this. And so if I'm going to calculate, I can then just multiply both sides by 6. And I get, if I do that, so times 6, I get 30/3 equals C. So I get that 10 is C. And from here, I can say, okay, 10 squared has to equal A squared plus B squared. And so 100 has to equal 36 plus B squared. And so 100 minus 36 is 64, which is B squared. So this is nice. So B is just 8. And so now I've found all of my missing pieces, H, K, A, and B. And so I can write my equation as Y minus K, which was 7, squared over A, which was 6 squared, so 36, oh, not squared, minus X, X minus -4, so plus 4 squared, divided by B squared, which is 8 squared, so 64 equals 1. And this would be my equation. Okay, we are going to actually look at, sorry if that was too quick. We are actually going to look at number 8, solving a system of equations. These equations will represent a hyperbola, but this process is something you've seen before and it's old, right? It's something that you've done in the past. So I just want to remind you what it is. So if I have equations like this and I want to solve this system, I can actually do elimination. You could do substitution, you could solve for y squared and then plug it into here, or you could do elimination by multiplying this guy by 2 and this guy by 2 and rewriting and getting 4x squared plus 2y squared equals 66. And then taking like this equation and this equation and adding them down so that you see these cancel. I'm left with 7x squared equals 84. And so then I divide both sides by 7. And I get x squared equals 12. And so I get x equals plus or minus the square root of 12, which 12 is 4 times 3, right? 4 times 3. So this is plus or minus 2 root 3. And so we found x. Now you can plug in x equals like the square root of 12 to find y. So you can pick either equation, but the first one's a little bit easier. So I would say 2 times square root of 12 squared plus y squared equals 33. And then I would, and it doesn't matter if you plug in negative here because it's being squared. So then this would be 2 times 12, which is 24. So y squared equals 33. And we subtract 24 from both sides, right? And we get y squared is 9. So y equals plus or minus 3. So then we get, this is our x, this is our y. And so our solution here is a system. It's a lot of solutions. It's 2 root 3, comma 3, 2 root 3, 2 root 3, comma negative 3, and it's negative 2 root 3, 3, negative 2 root 3, negative 3, right? So basically every combination of these, and if you were to, like sketch this on a graph, you'd get the 4 solutions would be, okay, like maybe here, 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 and here. Okay, this is not a good sketch, but it would be something like this. Oops. And if you were to graph this, this kind of forms it forms like a hyperbola, right? If you were to graph, the 4 solutions. So like these are the 4 solutions. And you could also connect the 4 solutions this way to make, to make another type of conic that, or kind of like an ellipse, actually. You can also connect them this way, which would make an ellipse, right? Okay, this extra practice I'm not gonna do, but you can see group the Y's together, group the X's together. Oh, is that the same problem we did before? It's the same exact problem, so it's not even extra practice. So, go ahead and try it again, right? It's good practice, but I think it's the same exact problem that we already did. So I just want to talk about this last page, and then I'm going to try to join back on the Zoom for the next section. So this last page is just over. Oh yeah, go ahead.
For the previous example, how did you get the plug this on the left?
These answers?
Yes.
Okay, so I took these 2 points, and I had 2 root 3 and 2 root 3 with these 2 points, 3 and negative 3, right? Because these are the X and the Y. And then I did every possible combination.
What do you mean every possible?
So let me write it out. So in this case, I get my answer here is X equals 2 root 3 and X equals negative 2 root 3. And then my answer here is Y equals 3 and Y equals negative 3, right? So I could pair these 2 up and these 2 up, and then I could pair these 2 up and these 2 up. And that's how I got all 4 of the answers, because your answers are in XY form, right?
Mm-hmm.
So that's how I got those answers.
Okay.
Yeah, good question. But for this last page, and maybe I don't need to talk about it too much, because this is just showing, and we haven't even done parabola yet. So really, I think this should be at the end of the next notes. But the conics overview, we talked about ellipses. We talked about, we didn't talk about circles, but this is something you should have seen, or you can see in the notes that I posted 2.2. We talked about hyperbolas, and next up, so this is maybe a good segue, is we're going to talk about parabolas. So it's basically showing you, this is the standard form of each of these equations. And if you were given equations like you could see below, A, B, C, D, you should be able to kind of guess what they will look like. If it's in this form, it's much easier because it looks, like nearly identical to one of these. So it's going to be one of those. But if it's in this type of form, what you want to pay attention to is, if I put it all to one side, first of all, could I get it equal to 1? Which most of the time it's going to be yes. If it can't equal 1, then it's definitely just a circle. But if it can be equal to 1, or it could be a parabola, I guess we'll talk about it. But if it can be equal to 1, so looking at like these guys, you would see, are the X squared and Y squared both positive? So in this case, they're both positive, right? But notice how like this one was minus. So because they're both positive, that tells me I can automatically cross off what we just did today, hyperbola, for those, because we need a minus somewhere, right? So I can cross that out, and I can say, okay, and it's also, it could be a circle maybe, but it also could be an ellipse. So it's probably going to be one of those. So I'd have to maybe do a little bit more investigating to figure that out. But I want to go through the last example with you, which is going to be a parabola, okay, which is the next section. So let me connect back on my computer. Start. Let's see if this stays connected. Okay, so I think it's connecting. I think it will. Hold on. Let me. Okay, this should be good. Just give me a moment to also get situated here. Okay, so I think we're back and we're good. But let me get to the, so these are the 11.2 notes. I will post those later tonight, and let's get to 11.3. Oh, and now I'm able to get, oh, nice. Michael solved it, right?
It's pretty easy.
Yeah, right. Okay, so I didn't want to take too much time, but that's just something really good to know and know how to do or how to solve, right? So this is important. Okay, but now we're going to talk about that last piece, and we'll do as much of this as we can. I'm hoping we can nearly finish. But so we're going to talk about parabola and conics instead of hyperbola and conics, and this basically just looks like half of. Well, to me, it's like half of a hyperbola. So if you look at this definition, a parabola is the set of all points in a plane that are equidistant from a fixed line, which we call the directrix. So instead of being like the transverse axis, we're calling the fixed line the directrix, and a fixed point, again, called the focus. So there's our focus. Here's our directrix. Directrix. That's like a tough word, right? And basically, we would take what this is saying is that if we took a point, so if we took a point on our parabola, and then we drew a line to the focus point and across to pretend this is straighter, but across to another point on our parabola, right? And then straight down to our directrix and straight down here. What they're saying is that, and this is not really drawn to scale or not done well, but this distance here and this distance here, these should be the same. And then, well, maybe I should have, and then this distance here and this distance here, these should be the same, right? So, well, I labeled them D, but so this is kind of what's going on. And then this distance to the focus point, we're calling P, and this point would be like 0P. Again, if we're centered, this is the origin, right? And we would call this the focus point. Okay. So now another reason it's maybe called the focus point is because if you thought like, if this was like a light bulb or something, I think mirrors is the better explanation, but okay, that's like a horrible light bulb. I don't know, but pretend this is a light bulb, right? And this is giving off like light in these directions, right? And if this is a mirror here, so that's what we're labeling this, right? And it's parabolic, so not, well, okay. Mirrors are like technically flat, but I mean, the mirror image, I guess, maybe is parabolic. But what we want to say here is if you move the mirror closer to the bulb, then you get a cone of light. Like you see this cone of light. And if you are right at, so what we'll say about this, reflections, like in the mirror, are actually perpendicular to the directrix. So the directrix again, like is here, right? At the bottom of the parabola. This one, it's the x-axis. And these lines going up are perpendicular. They're parallel with the y-axis. And that is the reflections coming off of the mirror. Okay. Is there a formula with P and D? Yeah, we're going to get to that. That's like the next part. Yes. And so I'm just kind of trying to give you, I guess, an example, but
Yeah, I looked at it, but there's not D on it.
oh, no. So D is just a distance. So, okay. So D.
I'm looking for the D's.
No, you don't want to look for that because what I mean here, this is just same. This is just the same distance. So they're D and D or A and A or, and I only labeled it D because I was going to refer to it, but these are just the same distance because we could pick, this point is not fixed. My green point, so my green point here and my blue, they're not fixed. You could pick a point here. And then when you draw this line, the other
But it's
point.
only distances.
Yeah. So it's D represented just distance. Yeah. But P is an actual, P is part of the focus point, right? And so that's actually going to be in our formula. So from right at the focus point, you get this like concentrated beam of light where it's straight and you can see whatever the reflection is. But if you move closer or further from a mirror, there's other reflections, right, of light, or even on your camera, actually. I only noticed this, well, with me and with everyone, right? Like the light behind me is like reflecting a ton, right? And if you have lights like right above you and you're on camera for work or school or whatever, like the angle it creates this other image and all this like light beaming, and it's reflecting perpendicular to whatever the focus point of your main I guess it would be your camera, right? So your mirrored like camera that's showing the image. So anyway, so this is just something that I guess you can apply it to. But what we're concerned about here, or what we're looking at, is this P value, whatever it is, right? It could go up, it could go down, it could be positive, negative, whatever. But the absolute value of it is called the focal length. And the reason is it's the distance. The focal length is just the distance from the vertex of the parabola to the focus point. It's the distance on your like axis of symmetry, kind of. Okay. If you think in terms of a parabola, it would be that distance. So, okay. And so now we're going to see that, right? So maybe I didn't have to say it. So here we have standard forms of an equation with vertex at the origin. Again, we always start vertex at the origin because it's just easy. So but in this case, we're just looking at a special
can't hear you, but I don't know.
okay, so everything just hates me. So we're just going to ignore the computer tonight. But okay, so hopefully you can all hear me, and maybe,
Yes.
there's not really a way I can pull up the chat because then you'll see it, I bet, while I'm sharing my screen. So unfortunately tonight, because then you see that, right? So that doesn't really work. But okay. Well, let's keep on. So these are just all the different types of parabolas that we have here, right? And we can see, like, this is kind of your traditional one. And then when the x-axis is our axis of symmetry, it's a little bit like more obscure looking to us, but that is when we would have y squared equals 4p times x, okay? And then they're just showing you examples of P greater than 0 and P less than 0. Whether it's going up, down, like up, down, or right, left, whichever way it's opening. That's what this means, right? Okay. And you can notice here that maybe these equations, like this equation is y equals negative P. This equation is x equals negative P. This equation is y equals P. And x equals P.
So the P is here a Foci.
The P is just a value, but it's basically the coefficient of x or y divided by 4. Based on this equation. So like, okay, so if we look at an example, we can see that, so given a parabola defined by this, right? Find the focus and the equation of the directrix. So this y squared equals 4px equals 8x. This means that 4p equals 8, so p equals 2. Therefore, the focus is, and we're starting at the origin, so the focus is just 2 to the right, because we're positive here, or we're opening to the right. So the focus is at 2, 0. And the directrix is going to be a vertical line. So it's going to be 2 to the left. So it's going to be x equals negative 2. And so then what this next, I guess, just note here is saying the width of the parabola at the focus point is the focal diameter, and it's equal to 4p. This is how we get this. So if this is our focus point, right? This is our focus, and these are just 2 points on the parabola, right? We just connect to the parabola. This distance here, this distance is the focal diameter, right? And it equals 4 times the absolute value of p, because it's a distance, so it's positive. So what that means is, if we want to know what p is, well, p, if we just divided this into like 4 equal parts, this is p, this is p, this is p, and this is p, right? But also, and I've kind of written all over it, but this distance is also p. And so this is just where it's coming from, and I guess going through that. I'm just so mad about Zoom right now. Okay. So now if we want to graph a parabola with a vertex at the origin, here is x squared equals 16y. So for this one, I know my, it's starting with x squared, right? So I know it's going to be, the y-axis is going to be my axis of symmetry. And I also can identify a few things. So 4p is going to be 16, so p is 4. And then I can identify, p represents, will get us to the focus point, right? So the focus is 0, 4. And the focal diameter, I can get that as well, because that is, from what you see above, 4 times the absolute value of p. I mean, that is 16. Okay. So that means it's 8 in each direction from the focus. So if I want to graph, oh yeah, go ahead.
So the focus, focal, foci, those all representing the same things?
The focus represents what?
Focal, focal, focus, and foci are representing the same points.
Yeah,
Like,
focus
we are
focus
still
is
looking
just
for the C.
single, is just singular. So focus is singular, foci is plural. And focal, yeah. Like focal point, a focal point is a focus, is the focus point. So yeah, they're all kind of the same thing. And basically what I just did was I counted like 4, 8, and then I counted from the focus point here. I counted 8 on each side, and I know I'm starting at the origin. So then from this, and just by having my focus and my diameter that I graphed here, I can actually sketch this graph, and this parabola should look, something like, okay, that's not the best sketch, but something like this.
Does this look like half of the hyperbola?
It looks like
The half of
oh yeah, it is. So a parabola is half of a hyperbola. Right? So, and in this equation here, we can also see it as y equals 1 over 16 x squared, right? Because I could rewrite this and divide both sides by 16. If we were using like transformations, this is how we would write it. But in this case, we were talking about vertex, focal, and focal diameter. Well, the vertex is 0, 0 because they give us that. Because it's at the origin.
Thanks.
Okay, and the axis of symmetry is just the y-axis. So this is the y-axis. So it's like x equals 0. And the directrix, so for this here, it would just be, actually that is the axis of symmetry. Oh no, sorry, the directrix is y equals 0. This is the y-axis. It's this here, right? And so it's x. Oh wait, did I write this wrong? It's y. No, I messed this up. It's the x-axis, and it's y equals 0. Okay. Because the axis of symmetry is where it divides, right, the parabola in half, and that's at this line, and the directrix is the bottom or top or side of from the vertex. It's a vertical or horizontal line from the vertex.
Should it be y equals negative p, the directrix? Directrix.
The vertex, this is just centered at the origin, so the vertex is 0, 0. The focus point is 0p.
Okay, so the directrix is negative p?
Oh shoot, it's not. Oh, right. The directrix should be, okay. Yes. So looking at this, I was connecting it to the vertex for some reason. So the directrix, you're right, is negative p. So this is going to be, I don't know why I was connecting it to the vertex, but this is going to be negative 4, right? Y equals, so y equals negative p. So y equals negative 4. And it will be 2, 3, 4. And it's this line here. It's equidistant. Yeah, so that's my bad. It's this point should be equidistant from the vertex as the focus point.
So the directrix is like, it means that I don't know, like the parabola is somehow related to the directrix. I don't.
Yeah. So the parabola, the directrix is a fixed line that is just equidistant from any set of points on the parabola. So basically,
Gotcha.
if I pick any set of points, right, and then I calculate the distance from here to like the focus point, all these distances are going to be equal.
That's cool.
Yeah. That's what it
Interesting.
represents. Yeah. And it's just because, I mean, it's half of a hyperbola. So it has this symmetry. Like parabolas have symmetry to them, just like hyperbolas and even circles and, ellipses. They all have this symmetry. And
Mhm.
it's because we're squaring it. Because when we square it and we take the square root, we always get plus or minus when we're solving. And when we get plus or minus, there's our symmetry. It's like plus one thing minus another, and those numbers are the same. Okay, so we're now going to just look at standard forms. So this is now the vertex is at HK. Okay. And let me see if I did this right. Yeah. So now our vertex is at HK. And we want to say, okay, what does that change? Well, it just changes it looks super weird. But again, my H is with X and my K is with Y. It just depends on if it's a vertical axis of symmetry or horizontal axis of symmetry, right? And then these are just like sample pictures of what it could look like in each case. And notice, maybe a few things to notice is that this opens either up or down, depending on if like it could be down if the point was down here, and right, okay. And this one opens left or right. And these points here is HK. This is the vertex HK. And then like this, the red would be a focus point, right? And so the distance here would be P. So if we want to try, we'll try a few examples here. So number 3.
So P is determined here. It's upward or downward.
P is determined. It's like the slope kind of. Well, but it's a parabola, so it's not really slope, but it's based on the equation. It's going to be in the equation.
So P is determined upward or downward or left or right?
So no, the up, down, left, right is determined by which one is squared. So if X minus H is squared, it's going to be up or down. And that'll depend on if this is positive or negative. And then if it's Y minus K squared, it'll be left or right. And then the left or right will be if P is positive or negative.
But the book says if P is greater than 0, parabola open upward, and if P is less than 0, parabola opens downward.
Yeah. So yes, that's correct. So okay, so here, but that's only giving you this case. So this case, P. Okay, so for this case, P greater than 0 opens up. P less than 0, it opens down. But then we have this case, right? And maybe I'll write it off. If P is greater than 0 here, it opens right. And if P is less than 0 here, it opens left. So it does determine, like the P value does determine, but it also depends on what value is being squared on the left-hand side. Is it the X squared or is it the Y that we're squaring? Yeah, I know it is a lot here. Okay, so let's try an example. So number 3 says identify the vertex, we want the vertex, the focus, and the focal diameter. And they give us this equation and then they say to graph it, right? So right off the bat, I know this is my K, this represents my H. Like this is X minus H, and this is Y minus K. So right off the bat, I know my vertex is going to be HK, so -2, 5. Right off the bat. And then I also know that this value is for P. So P is 2. And so I can also get that focal diameter it's basically just this number out front here because it's 4p. And so this is 8. And this means we go 4 up and 4 down from the focus point. And I guess I said up and down because I noticed that the y is the squared term. And so over here, it's going to be opening, well, I guess it's going to be opening left or right. Well, in this case, right. So now I just want to plot some of these points. So if I plot, so let's start by maybe plotting the vertex. So -2, 1, 2, 3, 4, 5. So here's my vertex, right? And then I can plot other points as I want, but what I'll plot first is going to be my focus point, which is 2 away from my vertex. And I know it's opening right because P is positive, because P is positive. So it's going to be here. This is my focus point. And then I move 4 up and 4 down from the focus to get my other points on the parabola. So 1, 2, 3, 4, and 1, 2, 3, 4. And then I can just graph, this is my parabola. Okay, and maybe this actually probably crosses the axis. I don't know why so something like this. Okay, we'll do number 4, and then I'm going to quickly kind of review some things, and I think it's just extra practice, so hopefully we can just finish this off. But number 4 says, write the equation of the parabola in standard form, and it gives us this whole chunk of change here, right? So remember, we keep the y's together, which they already have, but notice how the y is squared and the x is not squared. So this means that it's going to look a lot like this one because the y is squared. So we'll have to complete the square with the y and then move the 71 over. So we're going to get, well, here, I'll write a few steps. All right, 4y squared plus 12y plus 16x equals 71. Now I'm going to take out that 4. So I get y squared plus 3y plus blank. Then I'll get plus 16x equals 71. And this blank is 3 divided by 2. So it's divided by 2, then squared. So this is 3/2 squared, so it's 9/4. And I'll say plus 9/4. Oh, but it's times 4. So it's plus 9 on this side, because remember, it's multiplied by 4. And so now I can rewrite this to be, it looks a little weird, but I can say 4 times y plus 3/2 all squared, and then plus 16x equals 80. And then I want to get rid of the coefficient. So I want to divide everything by 4 because I don't want this coefficient here, right? So I get y plus 3/2 squared plus 4x equals 20. And then I want to, and you could have done this at the start, but now I want to move the 4x over because I want it to look, I mean, you can scroll all the way up, but I want it to look like this, right? So I have my y on the left-hand side all set up nice. And so I have y plus 3/2 all squared equals -4x plus 20, which I can rewrite this as -4 times x minus 5, right? And then I still have y plus 3/2 all squared. And so keep in mind, from here, this is now the same thing as y minus k squared equals 4p times x minus h, right? Where my vertex in this example is the 5 3/2. So it's 5 -3/2, right? There's my vertex. And my P is just, if I look at this -4, and that's 4P, my P is just -1. And so my final equation is this guy right here. This is my equation in standard form. Okay, so maybe I should have taken this off of the last notes, but this is the same exact thing. And now it should make more sense because we know what a parabola is now. We hadn't gone over this before. And just some things to note. Some things to note are that with the parabola, like the biggest difference here is that only one variable is squared. And in all the other ones, like they're both squared, right? So this is just something to note that's different about it. And then you also know from before, like the difference between ellipse and hyperbola is that one of them is addition, one of them is subtraction, right? And then a circle is really just an ellipse, but A and B are one. Like they're because basically, okay, so this is really just an ellipse with A equal to B. And you can see that because this is the same thing as x minus h squared over r squared plus y minus k squared over r squared equals 1. If I divided everything by r squared, so what I did here was divide by r squared, then it looks like an ellipse, and it is technically, but it's a circle, right? It's a perfect ellipse. Maybe it's an ellipse where A equals B. And then again, you can do I think actually, I wonder if these are exactly the same. And if they are, I know Michael did give those, he typed those in the chat. So I'll just write it real quick. And I think they're the same, right? Hyperbola, ellipse. And if they're not the same, well, sorry, spoiler alert that I'm giving you these, but you should verify these yourself. Okay. I'm just not going to take the time because we do have a lot. We've covered a lot today. And then this last page, it is extra practice. So I will not go through it and I won't post the answers just yet unless people like are asking about it, but I will most likely, so I'll table this. So let's say review during final exam review. Maybe I shouldn't say review. I'll say complete maybe. Complete during final exam review. And if we're reviewing other things and we don't get to it, these are, I mean, I can try to just post the answers or something, but these are good, just practice problems that apply what we just did with the parabola and conics and stuff like that. So I think it would just be, it just would benefit you to practice that. Now, I do want to say the question of the day before it gets too late is going to be, what is your favorite Thanksgiving tradition? So maybe you don't have one, but if you have a Thanksgiving tradition, something that you always do or your family always does, just type that in the chat. I can't see obviously, but maybe I will try to join last minute again for my computer. But we know that's just a nightmare. So I'm going to save this. So I know we did a lot tonight, but if people want to know also, oh geez. Here, hold on, brief moment. Oh geez, you couldn't hear me when I disconnected audio, my bad. So if people do want to, if they have questions or if let me know. But if you want to know the schedule for the rest of the semester, I can put that or kind of line that up for you right now, but otherwise have a great Thanksgiving break. You are free to go. We do have like 1 minute. But I went over 11.2 and 11.3 today, right? And so you do have 2 homework assignments that are due next Tuesday. So I gave you a week. If this is not true, please just email me, or if you need more time or whatever happens over the holiday and on Sunday, you're like, I haven't even looked at schoolwork, just email me. We will figure this out. And yeah, send me your favorite traditions of Thanksgiving in the chat. And the rest of the semester. So next week is our last full week of class, right? We will go over sections 8.1 and 8.2. I think that homework is due Sunday. Maybe I would push it to Tuesday. However, our final exam is that next Thursday. So next week we have full week of class. Then the following Tuesday, so 2 weeks from today, we will review for the final. And then the last thing we will do is take the final during class on December 8th, that Thursday. Okay, so hopefully.
Will you have normal office hours over those next 2 weeks? Because today